Hello, welcome back my dear friends. Welcome back to another exercise of integration. In this video, we will be learning today about integration by substitution using trigonometric identities. So this is also going to be a very important exercise because of its applications in the future exercises. So this is just not one exercise which can be just simply ignored and skipped and all. No, this will also train us. This will also again give us more practice on this topic of integration, especially with substitution. Trigonometry, who can deny the importance of trigonometry and its applications everywhere, integration, differentiation. So please do not ignore this exercise. Try to solve as many as possible from this textbook as well as from other textbooks also. That's my advice. The rest depends on how badly do you need to learn. Alright, these are just some of the formulas. If you remember some of the trigonometric ratios that I've written it down, which we will be needing today. There are plenty more, of course. Trigonometric identities, class 11, you can always go back and then just learn once again, especially the formulas. Always make a list of the formulas and keep it with you. That will be always very helpful for you. Okay, so fine then. Let's practice this exercise 7.3. You can pick up your books. You can pause the video here. Alright, after that we can start picking up your book, pen, paper. Let's begin with the exercise. So exercise 7.3. Let's begin with exercise 7.3. Some questions, not all definitely, yes. If you have any problems with any of the questions, please do let me know at the link comment section below. Definitely I will solve. So this is exercise 7.3. Let's start with the first question, that is integration of sine square 2x plus 5 with respect to x. So just a few moments earlier I had given you the formula for that. So okay, anyway, I'll just write once again. Sine square x or theta can also be written as 1 minus 2 cos 1 minus cos 2x divided by 2. 1 minus cos 2x divided by 2. So we will just apply that. So I becomes sine square. Of course, what is the value of theta here? 2x plus 5. So I think by now differentiation, integration, we have already had enough practice. 2x plus 5 divided by 2 with respect to x. So that will be simply 1 minus cos of 4x plus 10 upon 2. So as I was telling you that this exercise is a very good practice, okay, for our future exercises and all. So please do not ignore. Exercise as a whole may be revised for this term, but it doesn't mean that this is not needed, that's why it's removed and all. No, it depends on what is your future plan regarding mathematics, competitive examinations and so on. And then I want to make this known to you that these are simply exercises. We simply just cannot be just skipped and then we can just assume that okay, we are not going to be needing its applications. Definitely not. You move on to the other exercises, you will see these applications are required. So these are just practice, okay, practice. So mathematics, never fear for practice. X minus 1 by 2. This one also I just give you the formula there. If you have written it down, you can just check out there. So that's what done. So just to save some time and all, I'll just straight away write down, that is sine 4x plus 10 divided by 4 plus c. Because I've written the integration of cos of ax plus b is equal to what? Sine of ax plus b divided by the coefficient of x, that is a. Alright, so our solution integrand is 1 by 8 sine of 4x plus 10 plus c. I guess that's fine. Okay. Let's move on to the other question then. Question number 2 again. Question number 2 says integrate the function sine 3x cos 4x. Sine 3x cos 4x with respect to x. Now for this, again, I had given you another formula. We do not have the product rule. We have integration by parts, but that we'll be learning maybe after 3-4 exercises only, not now. So it takes time to learn all those exercises. So here we will learn again. We will see that it's quite simple, okay, using trigonometric identity. That is why I'm telling you again and again, this exercise is important. Don't just ignore this. It will teach you ways to integrate, okay? So don't just drop this exercise. Now multiply and divide by 2 because I had given you a formula. You can check that book. Those who did not pause the video, please go back and then again just pause the video and note down the formulas. Or if you already have the formulas, fine then, no problem with you. No problem. So twice I've multiplied and divided by 2 so that I can use that particular formula of twice of sine A cos B. You may have it with you, you may have already written it down. So let's see, what can we do there? So that will be what? Twice of sine A cos B will be sine of A plus B plus sine A minus B. Sine of A plus B plus sine A minus B. So that will be integration of sine 7x plus sine minus 1x with respect to x. Brackets, please. The whole function is to be integrated, okay? Now, here we know that from inverse trigonometric functions, we know that sine of minus theta is what? Minus sine theta odd function. Okay, so that will be 1 by 2 integration of sine 7x minus sine x with respect to x. So now we can just integrate. That's going to be 1 by 2. Integration of sine 7x will be this also we have already discussed. So I believe that you are regularly learning from the videos. So I'll not go back with some more time and explain. So sine of 7x is minus cos 7x divided by its coefficient instead of using substitution. Minus integration of sine x will be minus of cos x. So just to conclude, minus 1 by 14 cos 7x minus plus 1 by 2 cos x plus c. That's 1 by 14 cos x plus 1 by 2 cos x plus c. Alright, okay, so let's move on to another question. Let's say, okay, question number 4. Let's integrate the function sine cube of 2x plus 1 with respect to x. 2x plus 1 with respect to x. Okay, so what we can do here is maybe I can write this as sine squared 2x plus 1 sine 2x plus 1 with respect to x. I guess no harm there. No? Sine squared theta can be written, sine cube theta can be written as sine squared theta into sine theta 2 plus 1, 3. I'm just doing that. Why? I have some plans regarding substitution. That is 1 minus cos squared 2x plus 1 sine. This comes with practice. You will also understand all this, okay, with practice. See, this one, sine squared theta, 1 minus cos squared theta, because class 10th trigonometry, we have already seen this trigonometric identity. Sine squared theta is nothing but 1 minus cos squared theta. A simple job there. Now, let's see if I substitute sine 2x plus 1 as t. So then differentiating both sides, differentiating this, I'll have cos of 2x plus 1, chain rule, differentiation of 2x plus 1 dt with respect to x. So that's going to be cos of 2x plus 1. Maybe not cos, maybe not sine. I think I'll substitute cos. I think that will be better for us for the substitution. cos. So this is going to be minus sine. Nothing much is going to change, but I need to substitute this. That's why. Okay, so minus sine. So minus sine. So this term can be substituted. This here we have 2 dt with respect to x. So a little bit of arrangement. That is minus also. I'll take it on the other side. Sine of 2x plus 1 with respect to x dt upon minus 2. Alright? Okay, so once that is done, here what will happen is, once we bring back the substitution, therefore I is equal to, this will be now t square, 1 minus t square. This whole term becomes dt upon 2. dt upon minus 2. So that's minus 1 by 2, integration of 1 minus t square upon dt. So integrating that, minus 1 by 2, integration of 1 is t, with respect to t of course, integration of t square is t cubed by 3. I believe you know all this, that's why I'm not stressing much on these basic things now, because this is not the first video, so you can check the other videos also please. So that's minus t by 2 minus plus t cubed by 3 plus c. So I equal to minus, substituting back the value, 2x plus 1 by 2 plus cos cube of 2x plus 1 by 3 plus c. I think that will be just fine. That's question number 2 3s are 6. Sorry, 2 3s are 6. What am I doing here? Okay, 2 3s are 6. So that's, I think, alright. Minus 1 by 2 cos of 2x plus 1 plus 1 by 6 cos cube of 2x plus 1 plus the integration constant. Fine, right? Okay, let's go to another question. Let's say 5. Okay. Integration of the function sine cube x cos cube x. Sine cube x cos cube x with respect to x. Okay, what can be done here? Board exams will happen no matter what. I believe it's going to be offline only, because that will be, otherwise if it's online, I think it's not going to be justice for students. Of course, that will create more better competition, no? So whether it's offline or online really doesn't matter actually. Okay, let's just hope for the best. Offline, online, we shouldn't be really worried about that, to be very honest, to be quite honest. Offline, online, let it be, whatever be it, let it be. The ultimate goal is, are we ready with our preparations or not? Are we ready with our preparations or not? Because after this, you will be definitely sitting for the competitive examinations and all. So even though it's online, okay, it might be comfortable for us to prepare for our examinations and all, but for competitive examinations and all, you need to be ready with the entire knowledge. So be it offline or online, let it take care of itself. That's alright, no problem. Whatever comes, we will accept it, right? Whatever comes, we will accept it. Offline also good, online also good. That should not be our concern. Our concern is, are we getting the knowledge or not? Are we learning or not? Are we gaining knowledge or not? That should be our concern, because it's about the future. It's not about just the board exams. After the board exams, what are we going to do? Compete for the examinations. We have the engineering examinations. We have the medical examinations. We have so many examinations to write. There, your knowledge only will help you. How much do you know? Only that is going to count. Only that will count. So, offline, online, chalo, jo bhi hona hai, hone do. Whatever be it, let it be. You should not be really bothered about that. Offline also, as I say, good. Online also, no problem, isn't it? As long as we know, that's all fine. But primary goal, primary concept, please remember, what I would advise you is, don't be worried about what kind of an exams will be conducted. That should not be our worry. Our worry should be, are we learning? Are we gaining knowledge? Are we prepared to face the worst? Are we prepared for our competitive examinations and all? Now for that you need to work hard, you need to be honest with yourself. And just, yes, these videos are for you to learn, but practice and really learning for yourself will happen only when you sit alone on the study table and then you start practicing. No leaving aside all the videos or everything. No distractions, only when you sit on the table and then start practicing exercise wise. That time only you will know how much you've learned, how much you've gained. Okay, so please, time is running out. Time is running out. Please, my dear students, study well. I'm trying. I will definitely try my level best to help you as much as possible. You also try. Okay. Now differentiating, I've substituted this simple thing. So differentiating both sides, sine x dt. So sine x dx minus dt. Alright, so in that case, now if we go back to our substitution, so therefore I will be equal to 1 minus t square t cube minus dt. So that will be minus t cube 1 minus t square dt, integration of this function. That will be integration of minus t cube plus t power 5. Law of indices 3, 2. It's not going to be 6, okay, it's going to be 3 plus 2, 5. Or integration of t power 5 minus, just arranging, dt with respect to t. So that's going to be t power 6 minus t power 4 plus c. So that's going to be cos power 6x by 6 minus cos power 4x by 4 plus c. That was question number 5. 1 by 6 cos 4 minus cos 4 by 4. Okay. Alright, let's move on to another question. Done now. Let's go to 8 then. Question number 8. Okay. Equal to a simple question, 1 minus cos x. 1 minus cos x by 1 plus cos x. So this will require the knowledge of submultiple angles, or we call it half angles, which I actually gave you in the formula sheet. You can also, in the beginning of the video, you may have already written it there, so I'll straight away write down from there. Okay, so this is going to be 2 sine square x by 2, only the angle half, 2 cos square x by 2 with respect to x. 2 cancels. We have sine square x by cos square x. We have tan square x by 2 with respect to x. Now tan square x, we do not have the integration. That can be written as 1 minus sec square theta upon 2. So now integration of 1, so now integration of 1 is what? X minus integration of sec square theta. What was the integration of sec square theta with respect to theta? I think that was tan theta plus c, isn't it? You can just kindly check once. I guess that was it. Yes. So that will be tan square theta divided by, what did I say? 1 by 2. Coefficient of x. Coefficient of x is 1 by 2, isn't it? That substitution method which we had already mentioned before. So that means here it's going to be like sec square a theta. Similarly, I had actually told you about this. That will be what? Tan of a theta, where a is just another constant or the coefficient of the variable term here, divided by a. Alright? So simple questions regarding substitution I have already shared in the first 2-3 videos. So that's x minus twice of tan square x by, not tan square, tan x by 2 plus c. Alright, so this was question number 8, 2 tan x by t minus x plus c. I think I made some mistake there. Sorry, this was what? Just a moment, okay. Tan square theta is I think sec square theta minus 1, wasn't it? I'm confusing slowly, sorry. Because 1 plus tan square theta is equal to sec square theta. What did I do here? I'm very sorry for that. So tan square theta is 1 minus sec square theta. Of course, nothing is going to change, just the position, that's with respect to x. All these things will remain the same, just the integration term. I'm just confused slightly, sorry for that. So that's going to be integration of sec square theta will be tan theta upon the coefficient 1 by 2 minus x plus c. So that will be 2, integration of I will be 2 times x minus x plus c. Alright, I think that's fine by the textbook now. Okay, alright. I'm also human, mistakes do happen from everyone. All these small things, sometimes the moment we tend to become slightly over-complacent, that's when problem starts with mathematics. Mathematics, we just can't afford to be over-complacent, whoever may be it. No? Okay, let's go to question number 10. It is integration of the function sine power 4x with respect to x. Sine power 4x. What can be done here also? Sine power 4x. That's fine, I guess. Sine square x. Now, sine square x, as we have seen, 1 minus cos 2x divided by 2. These are all like revision of trigonometry only again. So that's going to be a minus b whole square. So that's a square minus twice of a into b plus b square divided by 4 with respect to x. Okay, I guess that's just about fine. Alright, okay, let's continue again. And I will be integration of 1 by 4 minus 2 cos 2x by 4 plus 1 by 4 cos square 2x. Now, still not ready for integration. I'll just keep this. I'll do the integration together for all the functions. Cos 2x by 2 plus 1 by 4. Now again, cos square x. So again, this formula again I have given you. Cos square x is 1 plus cos 2x upon 2. So it's going to be 1 plus cos 2x upon 2 with respect to x. Because see, cos x, but what is the value for our x angle here? It's 2x. So cos 1 plus cos of 2x. X is 2x. So that's the reason why. Okay? Alright, so let's simplify this. 1 by 4 minus cos 2x by 2 plus 1 by 8 plus 1 by 8 cos 4x. Okay, now 1 by 4 and 1 by 8 I'll just solve here. So I'll just simplify 1 by 4 plus 1 by 8. What will it be? LCM will be 8, 4 2s are 8 plus 1, that's of course going to be 3 by 8. So 3 by 8 minus cos 2x by 2 plus cos 4x by 8 with respect to x. Okay, now let's start with the integration. That's going to be what? 3 by 8 integration of 1 with respect to x minus 1 by 2 integration of cos 2x with respect to x plus 1 by 8 integration of cos 4x with respect to x. Now let's integrate 3 by 8x minus 1 by 2 integration of cos x. Cos x is cos ax. Substitution again. Cos ax is sine ax upon a, no? A, coefficient of the variable. plus 1 by 8 sine 4x upon 4 plus C. So just arrange. Minus 1 by 4 sine 2x plus 4x are 32 sine 4x plus C. Okay, so this was question number 10. So 10, I think everything is okay. 3 by 8x minus 1 by 4 sine 2x plus 1 by 32 sine of 4x plus C. Alright, so these are just practice. Let's do another question. Let's say 13. Let's try another question. 13. Question number 13. I is equal to, what is the question? That is cos 2x minus cos 2 alpha divided by cos x minus cos alpha with respect to x. Okay, what can be done here? Cos 2x. There are, of course, simplification. There are many ways. What I'll do here is cos 2x. I'll use the formula that I gave you, that is in the beginning. Cos 2x formula is 2 cos square x minus 1 minus here also 2 alpha, that is 2 cos square alpha minus 1. I hope this will be easier. So that's going to be twice of cos square x minus 1 plus 2 cos square alpha plus 1 upon cos x minus cos alpha with respect to x. So that we have here 2 cos square x minus 2 cos square alpha upon cos x minus cos alpha with respect to x. Done? Okay, so now what I'll do is, this is also done? Okay. So now what I will be doing is, I'll take 2 common. The next step, okay, I'll just write down 2 common out. Cos square x, come on, cos minus cos square alpha upon cos x minus cos alpha with respect to x. Now what is the formula? You remember the formula for a square minus b square? Yes, that's a plus b into a minus b divided by cos x minus cos alpha with respect to x. So now what we can see here is we can cancel cos x minus cos alpha and cos x minus cos alpha. So I'm quite lazy, so I'll just cancel here, and the next step will be something like this. Next step will be something like this. So now this we can integrate, that is integration of cos x with respect to x plus twice of cos alpha 1 with respect to x alpha. Remember, alpha is considered as a constant here. It's not a variable term. We are doing it with respect to x alpha. This will be considered as a constant. So here cos alpha will be out. Okay, this is angular. So this will be taken outside. We will not need this now. Will be considered as a constant value cos alpha. So you must be thinking, why have I taken out cos alpha here? No, I cannot be integrating cos alpha. Variable term is what? With respect to x here. That is the variable term here. So alpha here generally will be considered as a constant, arbitrary constant. So that will be twice of sin x plus twice of cos alpha into x plus c. So this is going to be my integrand. So this was question number 13, twice of sin x, twice of x cos alpha plus c. Okay. Okay. Alright, then let's solve another question. 17. Question number 17. What is sine cube x plus cos cube x? Sine cube x plus cos cube x by sine square x cos square x. Sine square x cos square x. It's very interesting, okay, once you really pick up and then start solving seriously, then it becomes interesting, but like boring, and then you'll never learn mathematics. You need to be dead serious if you really want to learn. Then slowly and steadily, you will see that all these things will come to you automatically. What do you think? We teachers are magicians or what? No. And every time we see a question, it just comes to us magic. No, those things don't happen. Whoever tells you all those things, no. For us, generally what happens is like the moment we see a question, the brain starts functioning, it starts functioning, okay, this is how you're going to do it. It starts calculating, but how does that happen? Because of the practice that we have put in, the labor that we have put in, the hard work that we have put in, and then years and years of teaching, experience, the practice. That's why it comes to us. The moment we see a question, our brain, just starts calculating, okay, that's how you're going to be doing it, that's how you're going to be solving it. So from there only we get an idea how are we going to be solving all this. It just doesn't mean that we were just born with trigonometry in our hands, we're just born with calculus in our hands, and those things don't happen. Okay, nobody's a magician here. Nobody just remembers all of it just by going through once. Tomorrow morning he just cannot say that I just with one look I remembered everything. Those things don't happen. It just comes with practice, experience, hard work, persistence, determination, patience. All this combined, years of practice. After that it comes. So you may be having problems now. Okay, some of you may be having problems. Some of you may be thinking that why am I not learning? Why is it so difficult only for me to learn? In that case, it's normal. You should be very happy that you're having problems learning mathematics or physics and all. It's good. It's a good thing. That means you are trying. You are trying. Only students or only the people who do not study have no problems in life. In education, I mean. In education. Anybody who studies seriously will always be filled up with problems, questions, not to be answered. Why, what, how. So if you're having lots of problems, not understanding, confusing, that's a very good thing for you. That means you're trying. That's good. That's normal only. Don't worry. Slowly things will start. You will start understanding things. It takes time. Have patience. Honesty, very important. Humbleness, very important. 10x. See, what am I doing here? Nothing. Trigonometry only. Cot x. Cosec x. So that's why lazy people will never learn. That's why I was telling you now. Offline, online exams. Why are you worried about that? Let it be, whatever it is. Offline also, as I say, the government or the board will always decide what is best for you. Let them decide. Let them make that decision. Why are you taking that headache for yourself? Let them decide. You do your part. Study, prepare for the worst, and be ready. Because for the future, you are the future, my dear students. You are the future. You are the future. So you need to be ready. You need to be qualified. You need to be skilled. I know you are all. You just need to brush up a little bit. Okay, what is integration of tan x sec x? Integration of tan x sec x. That was. What was integration of tan x sec x? Integration of tan x sec x. Integration of tan x sec x. Tan x sec x. What was it? Just quickly. Integration of tan x sec x. Integration of tan x sec. That was sec x minus integration of cot x cosec x minus cosec x plus c. I think this is also fine. Which question was this? Question number 17, sec x minus cosec x. Okay? Alright. Let's solve another question again. 19, chalo. Question 19. I equal to integration of 1 by sine x cos cube x. 1 by sine x cos cube x. I hope that you're not watching the video on your bed lying down and then just watching as if you're watching a video, movie and all. I am not an actor, please. I'm not an actor. You're not watching. I'm not producing a movie here. I'm not directing a movie here. Please go and sit on the table. Take out your pen and paper and start solving along. That's why I'm going slow. I'm waiting for you so that we can do it together. Classes. Assume this as a class only, because now offline classes are quite impossible. So assume this as a class. Every day, set the timetable for you. Okay, this time to this time, I'm going to watch, I'm going to learn, I'm going to attend class. Something like that, please. Okay. Anyway, let's continue. What are we going to do here is here. I will multiply and divide by cos x, tan x, sec square x. See, that's how it works. The brain starts functioning, it's functioning. Let's see whether my brain functions properly or not. Integration. No, that's one problem, because integration is quite limited. There are few ways to solve a particular problem, so you have to work out. I think my brain worked out. Let me just ask. So that is done. Then I should have brought this down only. Tan x sec integration of tan x, differentiate tan x, substitute tan x sec square x. Let us just do one thing. Okay, this cos x, instead of, it's all the same only, but instead of multiplying, I'll multiply and divide here. Cos x. I guess that's fine, because this cancels 1, you get the question back again, so not a big deal about that. So this will remain as 1 only. But because of that, see, a lot depends on how we arrange our problems also. So now because of that, what will happen is this will become tan x. Okay, I'll just write into 1 by cos power 4x with respect to x. So then this becomes 1 by tan x sec power 4x with respect to x. Now what I was telling you was, if I substitute tan x as t, then differentiation of tan x is sec square x with respect to x is equal to t. I think I will be able to do something with that. Okay? So then my integration becomes, okay, sec power 4x, at least for this I'll write sec, maybe a little bit more arrangement. Substitution already done, so I'll substitute that later on. Sec square x, what was that sec? We made one mistake in that previous question. 1 plus tan square x is sec square x with respect to x by tan x. I think that's fine. Okay, now with the substitution, that will be 1 plus t square. This is dt by t. Alright, so I hope that's why, tan, if I substitute, I get sec square, which I can be, which I will be able to solve. That's what I'm working out on. So this will be 1 by t plus t square by t. So that will be 1 by t plus t. derivative of t. So now this one, if I integrate 1 by t, integration of 1 by t is log of t, plus integration of t is t squared by 2 plus c. So that's going to be log of t was tan x plus this is tan square x by 2 plus c. Chalo, I think that's fine. Let's hope that we don't have to correct it again. Yeah, everything is fine. Okay, na? Okay, shall we do one more question? One more, let's say 21. One more question, let's say 21. That is integration of sine inverse cos x with respect to x, sine inverse cos x with respect to x. Okay. Remember, I gave you another formula regarding inverse trigonometric function which states sine inverse x plus cos inverse x as pi by 2. So, can we apply this somewhere? If I just assume this as theta, which is less than 1, I think something can be done. What do you say? Or if I substitute cos x as t, no, that's not going to work out. So I think we can use this because in that case, sine inverse x will be pi by 2 minus cos inverse x. So in inverse trigonometric functions, you have studied what are the conditions with this. So I'll just apply that directly here. In the topic of inverse trigonometric functions, I'll be discussing about the conditions also. So that's going to be cos inverse x. But what is the value of x that I'm applying using here? This one, cos x. Cos x with respect to x. Okay? So that will be pi by 2 minus. Now, cos inverse cos theta. This also we have studied that it's going to be theta. So that's simply x. With respect to x, so integration of pi by 2, 1 with respect to x minus integration of x with respect to x. So that's going to be pi by 2 into x minus x squared by 2 plus c. Pi by 2x plus minus x squared by 2 plus c. Okay. Alright, now since you have been already too patient, I will reward you with another question that is 22. That looks like a very interesting question. So we'll wind up with that question, 22. So you can pause the video, go bring a glass of water, a cup of tea, whatever be it, and then let's do one more question. Even I'm also tired, exhausted, but you know, for studies, teaching, no problem. Cos of x minus a. I'm very thankful to all those who are watching the video till now. Heartfelt gratitude for all of you because you are the true students who are watching this. So please do let me know in the comment section who have watched till this section so long. Please do let me know in the comment section that sir, I have watched, so that my heartfelt gratitude goes to those students also. That means my hard work is not in vain. There are students learning from this particular video. I will be very encouraged. I will continue to do more and more for you. Okay? So I need encouragement. I need encouragement. Every human being, we need this encouragement. So please, do let me know in the comment section below who have watched so far. Okay? Alright. Now here, in this problem, what I will have to do is, there will be other ways also, as I always say. 1 plus 1 is 2. Half plus half plus half plus half is also 2. Mathematics, no definite specific. We have different frame of references. Sine of a minus b. Sine of a minus b. What is this guy doing? Don't worry sorry, I'm getting to my point here. I am multiplying and dividing by sine of a minus b, because what I am thinking is this a minus b, if I just add and subtract if I just add and subtract x, that's also fine, isn't it? If I just add and subtract x, will that be fine? In that case, of course, small problem, minus a minus b plus a. Instead of that, I think, because minus a minus b, I will multiply b minus a. B minus a, I guess that would be better for us, b minus a. So, plus b minus a. Yeah, now that's perfect. So then I'll have x minus a minus common x minus b. I hope you're getting where I'm going, isn't it? You will get to see. You will know very soon. And that's what practice does for us. So, okay, done now. I'm going to rub this part. So 1 by sine of b minus a. See, that's how. Then automatically we just cannot predict what is going to happen. So we just have to arrange, make some arrangements. No? Sine of x plus, x minus a. Now I'll click arrange. Minus x minus b. Cos of x minus a. Cos of x minus b. Now I think that's all set there. Now, remember the formula? Sine of a minus b. What was the formula? Sine a cos b minus cos a sine b. We'll try to use this formula now and expand and see what do we get. 1 by sine of b minus a, integration of sine a cos b minus cos a sine b with respect to x. Now this common denominator, I'll just to save some time and reduce some steps, I will just factorize here itself, okay? Minus cos x minus a cos x minus b. Got my point, no? Actually we should be writing like all minus something like, I hope you got my point, minus all divided by the common denominator. So this I'm just doing something like this, 5 by 7, 5 plus a divided by 7. I'm just trying to write like this directly. 5 by 7 plus a by 7. I'm just trying to do that only, okay? Just to save some time. How did this come? Okay. I'm also, I think, getting tired now. This one done. This one done. So that's 1 by sine of b minus a, integration of tan x minus a minus, this becomes again tan of x minus b with respect to x. Almost there. Almost. Alright, now next formula that we are going to be using is tan x with respect to x. In that integration by substitution, I give you this formula also, that is minus log of cos x plus c. So let us apply. So then I will be 1 by sine of b minus a Integration of tan x minus a will be minus log of cos x minus a. No coefficient with x, coefficient of x is 1 only, so no problem. Minus, again, tan of x minus b will be minus log of cos x minus b plus c. So 1 by sine b minus a minus log cos x minus a minus plus log cos x minus b plus c. So this one I'll do it directly just by arranging, that is, don't want to be wasting too much of time here. Log of cos x minus b cos x minus a plus c. Because we know na, log of m minus log n is log of m upon n. So log of, this is plus, log of m minus log of n is log of m upon log of n. All right. Textbook answer is a minus b. Okay, that also can be done. Okay, I'm also confused with that, but no, don't be confused. That also can be done. See, I'll give you the textbook answer. Some of you may be thinking, how come? Everything is fine, don't worry. What I'll do here is, no problem, sine of, don't worry, minus a minus b. I've taken just minus common. This, let it be as it is. I will arrange later on. Cos of x minus a plus log of cos. The first one is also correct only. Okay, your teachers will understand that part also. Don't worry about that. But just to have the textbook answer, it feels much more better. We feel more comfortable, isn't it? Sine of minus theta, as we know, minus sine theta. So that's going to be 1 by minus sine of a minus b. This again minus log of cos x minus a plus log of, I'm wrapping this, cos x minus b plus c. Now this negative value, if I just bring it inside, that will be plus log of cos x minus a minus plus minus minus log of cos x minus b. What I gave you in the beginning, that first solution, that is also correct only, okay, but after I saw the textbook answer, I saw it's slightly arranged, so maybe right from the beginning also, it's all the same, don't worry, don't panic. Cos x minus a, if I had known the answer that it would be arranged or something like this, maybe right from the beginning we could have taken minus also, we could have solved also. But the previous one is also correct, because from the previous one only we're getting this proof also again, isn't it? The textbook answer also. So you can see, if you wish, you can have this also, no problem. Otherwise we can leave it there also, absolutely no problem at all. Okay, they will understand, we will understand what you've written there. So there, I don't see any problem there. I hope I'm not wrong there, but I don't see any problem there. That's how I've got the solution also, no harm done here. Okay, so alright then, so that's it. This is okay, no? Again, as I'm mentioning, the previous one is also no problem, no, it's fine. I've just done this so that it tallies with the textbook answer. I've got this. Maybe right from the beginning taking minus common, and then maybe from there also we could have done. Who knows? I guess we could have done. Definitely, surely. But that's alright. Procedure is no problem with that. And the textbook answer, this answer, I've just tried to match only. So don't be so worried about that. Okay, everything is fine. The previous one is also correct. This also is correct. Until unless suppose the question says prove this, prove that. Okay, that time we'll have to match. Otherwise, I think both will be termed correct. So don't worry about that. Okay, do not worry about that. This is just the textbook answer. Got my point? No? Okay. Alright then. Okay then. So fine then. I'll see you in the next video with a very important chapter, that is exercise, that is integration of special integrals. So okay, we are going to now slightly more not difficult, I would not say, but we're getting into integration now. So please be prepared before we really jump in the world of integration. This is also important, deeper I mean. Okay. Alright then. Thanks for watching. I'll see you again in the next video. Keep safe, study hard. Bye bye. Take care.